So the services of operating systems are, first of all, the program execution. This is one of the main tasks handled with the operating system. Input output operations. Input output means basically connect input devices and then also interact with the output devices, so handling both input and outputs. File management, communication, resource allocation like allocating memory, um, and then error handling, and then protection facilities, right? So then we briefly discussed the booting process and then the evaluation of operating systems. Now, very early days, we didn't have any operating systems as all, which means ENIAC. I told you there are like only just the bulbs, no software at all those days. And then we had batch programming, batch system. That means the jobs or the processes are executed one after the other. And then multi-program batch system. And finally, we have sharing, right? Multi-programming batch systems, what we discuss is, whenever program runs and during the wait time, the other program started running and then actually make use of improve the execution. Time sharing actually went further on down. So basically it's use multiple jobs and then the processor time is shared, right? So by doing this, multiple users can access the operating system. Then when we look at the main functions operating system, um, process management, memory management, device management, file management, security management, and then providing interface. So those are the things that we have discussed. Mainly processors, that means when you run a software, it will create one or more processors, and then for a given time we know that only one processor can operate on CPU, right? And then so the processors activate in a particular order, right? And then memory management, so the memory should be allocated for each of these tasks without any issues. Then device management, like I told you earlier, you have to communicate with various types of devices, which we call peripheral devices. And then, we have to have the piece of software to communicate with particular device, and which is called device driver, right? And then we have file management, which means creating files, creating directories, giving different accesses, backing up, and security. So all these comes under. And then security management, um, you have to protect the system, especially users. We have to get the authentication, and then for that you can actually use username or passwords, and we need to prevent from unauthorized users. Then firewalls, we know that when we connect the internet, especially other persons may come into our network system. If they have not authorized, we should block. So the incoming connections coming from the outside should be carefully looked at, a software like firewalls. Then providing interface, there are user interacts through the interface, and there are many interfaces like this: command line interface as well as graphical user interfaces there. Command line, we had what we call the shell. Whereas in graphics, we have different graphical elements to interact with the system. Then we discuss the classification of operating system depend on how many users they are using, as well as how many tasks you can execute a particular given time. So we discuss a single user single task, single user multitask, multi-user multitask, multi-threading, and then real time, time sharing. Even we went on discussing distributed OS. Then we went to section 2. So in the section 2, we look at particularly on file management. We started looking at what a file is. And then the different views, and then different file attributes, and different file types, and then organization, right? File structures. We look at the file structures and file systems. There are different file systems are there. So we detailed discussion on the file system. Then file security, how you are going to secure the file, especially use of password and access privileges we have discussed. And then storage management, how when you store a file, you cannot store the file or the parts of file in the same place. So you make it to what we call blocks. So when you make a blocks, that means small pieces of the file, there should be a way to allocate it. So this is called file allocation methods. So in continuous allocation, we discuss with this example. For example, ABC text, the files are stored between 0 to 3, 0, 1, 2, and so on. So the length is 3, the blocks allocated is 3. Then video, again, start with 4, length 2, that means it assign blocks 4 and 5. So that means when storing a file, contiguous allocations is given. JTP docx, again 9, 10, 11 blocks are there. So which means whatever the blocks we put together. But this is not a very practical way of doing this, but it's sometimes very difficult, right? Especially later on, if you want to increase the file size, then you can't do this because we are not keeping space there. So the second way is called link allocation. What we need to record only the starting point of here, and then all the other blocks contains the information about the next block. So we keep track of the first block, and when you visit the first block, we know what is the second block, and then we know what is the third, fourth, fifth, and so on. And at the end, we know that so when there's a next link, we know that this is the place where you need to stop, right? The advantages is no fragmentation, and then what we need to keep track here is only the starting block address, right? So file size can be changed easily, but there are problems. Direct access is not possible, or random access is not possible, right? So you have to travel every block there. Then index allocation, that means you have a dedicated block which keep track of where the blocks are, right? So that in this particular case, block number 19 link into all the other parts of the blocks there. So you can directly access the information, right? And finally, we were discussing fragmentation, defragmentation. Now we discuss how files are allocated into pieces, and the problem might be after some time, some of the blocks might be in here and there, different places. This is called fragmentation. The process of defragmentation is you get all these pieces together, keep it in a one single place. That process is known as defragmentation, right? So when you have fragmentation, slow start up is there, higher drive failures could be happen, and file corruptions are there. So you better defragment. And finally, what we discuss is how to maintain the secondary storage, the needs of outcome of formatting. So the disk formatting should be done when you work with the secondary storage. I think this is the place where we have stopped, isn't it, Nimesha? Hello.
Oh, sir, honey.
All right. Right. Let's move on to the next one then. So the next one, we are going to look at the 5.3. So in 5.3, we are going to look at how operating system manage processes in computers. Now, we discuss in detail how files are handled. Now we are going to look at in detail how processes are handled. Now, what is a process? We discussed the process is nothing but when you create or when you open up a software, it will create a one or multiple processes. So we'll start with the process. So program becomes a process. So when a program executes, it will create a process, right? Then now, for example, let's say you open a word might create multiple processes. Now let's say we are using the browser, we open multiple tabs. Let's say we are visiting multiple website, that will create separate processes, right? So when it comes to processing, these processes controlled by what we call the kernel of the operating system. I told you the main part of operating system is the kernel, right? And this controlling is called process management. We need to manage the processes because we discussed there were some limitation. Now when it comes to CPU, for a given time only one process could be accommodated, right? So we have to order in very many ways, right? Now for example, process could be in main memory, and then available the main memory, then running the processor, and then certain processors may have been directed to the virtual memory, which means if you do not have enough memory, we will put the a memory in the hard drive, which is called virtual memory, right? So let's look at these details. So let's write down the uses of operating systems to manage the functionality of computers. How we'll put it like this. Let me type uh, how managing OS. Right. So let's look at the managing processes by operating system. Right. First, we need to discuss what processing is. So we need to discuss this in detail. As I told you, like, so when it comes to your process, I told you like creating a software. When you open up a program, it will create a process, and then you have to create the process when you open up a software, one or multiple, and then you have to schedule, you have to order it, and you have to finally finish it, right? So I think first we'll start with looking at what a process is, right? Now there are two different things we have to look at it. Now, for example, program as well as processes. Now process is a program in execution, right? And then when you are running the code of a program, then it becomes what we call the process, right? So that's what the process is, right? So let's write down. A process is an instance of a program in execution. When running a program, it becomes a process. When running a program, it becomes a process. Right. Now we discuss process management. Now, when you create a running program, uh, depend on the program, it may create multiple processes. So we can say it becomes a, a process when we say oh multiple process, or it becomes multiple process or becomes a process. For example, when we open URL in a browser, it creates a process. Right. Now let's look at the process we have described. Now we describe interrupts. This is a subtopic. Interrupts. Right. So this is a subtopic. When a process needs an attention of operating system, it it creates an interrupt. This will request the change of order of process execution. There are two types of interrupts: software interrupt and hardware interrupt. Software interrupt means sending an interrupt message by another process. Hardware interrupt means interrupt message coming from hardware. පොතාලියගෙන ඉවරලා මට කියන්න.
Hi, sir.
Okay, so next paragraph under the interrupt, how we manage interrupts, right? When interrupts happens, happens, always stop executing the current process, save, and then saves the states. It will start executing the interrupted process which uh, generates the interrupt, generates the interrupt, and after finishing, it will continue the previous process from where it was stopped. When interrupt happens, operating system stop executing the current process and then saves the status. It will start executing the process which generates the interrupt, and after finishing, it will continue the previous process from where it was stopped.
Hi, sir.
Okay, Puti. Now let's move on to process management. Now, if I start from beginning, process I told you is an instant of programming execution. When you open up a program, when you run a program, it will create a process or set of processes. Interrupt is now when you have multiple processes, one process is taken by the CPU and it will execute it. ඒ කියන්නේ එක process එකක් තමයි එක සැරයකට execute කරන CPU execute කරේ. When another process need the attention, it will create what we call the interrupt. Interrupt means it requests immediate attention, right? um, when we need the immediate attention, it will create an interrupt. When there's an interrupt, operating system stops the current process, execute the interrupted the process interrupted um, process which requests interrupt and then come back. උදාහරණයක් විදිහට මම මෙහෙම කිව්වොත් පොතේ දැන් printer එකේ අපි print out එකක් කියවනවා අපි වැඩක් කර ඉද්දි හැබැයි printer එකේ කොල නැහැ. ඒතර print වෙන්න බෑනේ. ටග් ගාලා printer එකේ message එකක් operating system එකට එනවා කොල නැහැ කියලා. ඒක අපි මොන වැඩේ කර හිටියත් ඒක ටග් ගාලා display වෙනවා. Right? So that's called interrupt. Interrupt means sometimes when some other process needs the immediate attention of the operating system, it will give you. Now you see, so we need to handle these situations. We have different situations, isn't it? ඒ කියන්නේ අපි program ගොඩක් run වෙනකොට ඒවට එක විදිහට අපිට manage කරන්න වෙනවා. So we need process management, right? So let's write down a subtopic, process management. So there are multiple processes, and then process management involves process creation, creating a process, scheduling, termination, scheduling and termination. It also protects resources allocated to each process and synchronization among processors. Operating system is responsible for managing all the running processes of the system. This is done by process scheduling and resource allocation.
හරි සර්.
Right. මේකෙදි කියන්නේ මෙහෙමයි දැන් there are multiple processes are there. The process management means creating processes. Process එක දැන් අපි කිව්වා when we run a program it will create a process. ඒතර process create කරන එක. process schedule කරන එක. ඒ කියන්නේ අපි දැන් ගොඩක් ඒවා තියෙනකොට ඔක්කොම එක සැරේ අපිට execute කරන්න බැරි නිසා we have to have a schedule. Which one should execute now, then after that, and we have to have some schedule. And termination, the finishing of a process. So process creation, scheduling, termination involved in process management. Then each of the process need different resources like different memory, different space in hard disk, so it should protect them, right? Otherwise what will happen, there could be clashes. You have to allocate when multiple processors are running. You have to allocate separate memory, separate hard disk space for each of these processes. And synchronization means you have to synchronize the values should be the same in all these processors. If it is involves some sharing some place, you have to share the same values. Then operating system manages all the running processes of the system. So because of that, operating system is responsible for running all these systems, and it does this using scheduling and resource allocation. Right. Now I think we discuss process management. Now I think we can look at you know different process states, right? Right. Let's look at process states. That means when you create a process, there are different states are there. Process states. A process state is a condition of the process at a specific instance of time. It defines current position of the process. So let's draw a diagram first. What will happen in the diagram? So let's look at this. So process will be created. We told that the states process in different states, right? Let me take we'll put up this. පොතේ මේක ඇඳගමුද? මෙතනදී වෙන දේ මම පැහැදිලි කරලා ඉන්න. දැන් process state එකක් කියලා දෙයි මේ තියෙන state diagram. We call it a state diagram. So this is called process state diagram. So this will show you different states of processors. Yes, different states of processors when it comes to executing the process, right? So initially when you open up, it should create a process. So that create a process will create in a main memory. But you know, CPU is executing one particular process, so you have to wait. So that's why it's in waiting. Once the CPU takes the process and running it, it will in the run state, right? And then after finishing that, it may terminate. But sometimes you know that when you're running, right? When you're running, interrupts happen. Remember, some other process takes the attention of CPU. Then you will put a block stage, right? And then maybe you can put in the waiting stage. And if it is a further delayed, it's swapped out, meaning like you put in the virtual memory, secondary disk, right? Same thing could happen here as well. So that's how this will handle, right? So you will have different stages like created, that means the new, and then you are waiting, or we call ready, then running, and termination. So there could be blockages are there, then swapping out waiting and swapping out and block. So these are the different states are there. We will discuss the states later on. So let's take down this. පුතා මේක ඇඳගන්න ඉවරලා මට කියන්න.